A cropping pattern is the yearly sequence and spatial arrangement of crops on a given land area, a district, a part of a state, or a part of a country, or even a farm. An operational holding may be consolidated and enclosed and used for agricultural production. The cropping pattern is the crop production activity of the farm or holding and their interactions with farm resources, other household enterprises, and the physical, biological, and technological and socio-economic factors or environments. In 1960, the Government of India, for economic and statistical purposes, gave the definition of cropping pattern as the proportion of area under various crops at a particular time in a given area. Thereafter, there have been changes in cropping patterns due to the following causes: developing of high yielding and short duration varieties in main crops, development of production technology to grow them, incentives and innovations provided by the central and state governments, spread of irrigation, development of fertilizer production and technology, government special programs enhancing the production of particular crops, changes in the socio-economic conditions of the people due to rapid industrialization in the country and transformation of subsistence agriculture into market-oriented economy. Traditionally, increased food production has come from bringing more land area under cultivation. However, in large areas of the world, especially in Asia, all the land that can be economically cultivated is already in use. In future, most of the extra food needs must come from higher production from land already being farmed. A major share of this increase is likely to come from increasing the number of crops produced per year on a given land using improved crop cultivars. Such multiple cropping offers potential not only to increase food production but also land degradation. The ability to grow specific crops in certain areas at specific times is largely determined by the seasons. The period of time during which a specific crop can be grown in a certain area is called the growing season. In agronomic terms, the growing season is primarily determined by patterns and depends on the following factors like rainfall, temperature, humidity, sunlight, and wind. Across the globe, we find a wide range of growing seasons. In some areas, we have winter, spring, summer, autumn seasons, each with different rainfall, temperature, and sunlight patterns. Some crops are better suited to various seasons. For example, in the cotton belt of Australia, cereal grains are better adapted to growing over winter and spring, while cotton and corn are better suited to summer and autumn growth. In tropical areas, seasons are often classified as wet or dry depending on the monsoon patterns. Sole cropping or monocropping, that is monoculture. It refers to growing of only one crop on a piece of land year after year. It may be due to climatological and socio-economic conditions or due to specialization of a farmer in growing a particular crop. Under rain-fed condition, groundnut or cotton or sorghum are grown year after year due to limitation of rainfall. Flue-cured tobacco is grown in Guntur district of Andhra Pradesh year after year due to specialization of the farmer in growing it. In canal irrigated areas under waterlogged conditions, rice crop is grown as it is not possible to grow any other crops. Double cropping, cultivation of two crops in succession on a piece of land in an agricultural year. Examples: rice followed by wheat, or potato or mustard, maize followed by groundnut. Multiple or polycropping, growing two or more crops on the same piece of land in one calendar year is known as multiple cropping. It is the intensification of cropping in time and space dimensions, that is, more number of crops within a year and more number of crops on the same piece of land at a given period. Or this is a cropping system in which two or more crops are grown in succession within a year. Examples: rice, potato, green gram, rice, mustard, maize, rice, potato, sunflower, rice, wheat, moong. Cropping intensity is more than 200% under this situation. Multiple cropping is of three kinds, namely intercropping, mixed cropping and sequential cropping. Let us study the first one, intercropping. Growing two or more crops simultaneously on the same piece of land with a definite row pattern. For example, growing setaria plus red gram in 5:1 ratio, that is, after every 5 rows of setaria, 1 row of red gram is sown. Thus, cropping intensity in space dimension is achieved. Based on the percent population used for each crop in intercropping system, it is divided into two types, namely additive series and replacement series. In additive series, which is mostly adopted in India, one crop is sown with 100% of its recommended population in pure stand, which is known as the base crop. Another crop known as intercrop is introduced into the base crop by adjusting or changing crop geometry. The population of intercrop is less than its recommended population in pure stand. Second one, mixed cropping. Growing of two or more crops simultaneously intermingled without any row pattern. It is a common practice in most of the dryland tracts of India. Seeds of different crops are mixed in certain proportion and are sown. The object is to meet the family requirement of cereals, pulses and vegetables. It is also known as subsistence farming or cultivating two or more crops simultaneously in the same field without keeping their identity with respect to field area. Examples: maize plus cowpea plus groundnut. Third one, sequential cropping. It can be defined as growing of two or more crops in sequence on the same piece of land in a farming year. Depending on the number of crops grown in a year, it is called as double, triple and quadruple cropping, involving 2, 3 and 4 crops respectively, or cultivation of crops in sequence or raising a crop after harvesting one. In general, the sequence of crops is maintained season after season for 1 or more years. Examples: rice, that is practiced in Kharif, potato practiced in Rabi, maize practiced in summer, rice, potato, jute. Relay cropping. It refers to planting of succeeding crop before the harvest of preceding crop. The crop may be done before or after flowering, before or after the attainment of reproductive stage, completion of active life cycle, senescence of leaves or attainment of physiological maturity of the crop, or growing of crops in succession. In this cropping, the crop in succession is sown or planted either in the field of the standing crop, which is going to be harvested soon, or in the nursery, so that immediately after the harvest of the standing crop, the subsequent crop can be transplanted in the same field without any allowance for keeping the field uncropped or fallow even for the turnaround period. Example: maize, potato, maize, turnip, ragi, horse gram, jute, rice, mustard, onion. Keeping the above information in view, let us study the objectives of relay cropping. Let us know the advantages and disadvantages of intercropping. Advantages of intercropping: additional income from the companion crop. If the principal crop is damaged due to unfavorable conditions like drought, flood, etc., companion crop may give sustenance income. Legumes grown as companion crops always benefit the principal crop through nitrogen fixation and also utilize soil moisture from deeper soil layers. Quick growing companion crops always suppress the harmful weeds thriving in the interspaces of the principal crops. Gainful utilization of the labor by increasing more man-days employment potential. Better utilization of growth resources like nutrient, water, light and space. Less incidence of insect pests and diseases attack and less erosion losses. Let us study the disadvantages of intercropping. The fertilizer management is difficult because the nutrient requirement of the crops is different. Difficulty in harvesting due to different seeding time of crops, and there are certain combinations which suppresses the growth of another crop and may be conducive to insect pests and diseases. Intercropping was originally practiced as an insurance against crop failure under rain-fed condition. At present, the main objective of intercropping is higher productivity per unit area in addition to stability in production. Intercropping system utilizes resources efficiently and their productivity is increased. In monocropping of groundnut, climate resources like rainfall, temperature and solar radiation are utilized only during rainy season. When red gram is introduced as an intercrop, these resources are used up to the end of winter season. For successful intercropping, there are certain important requirements need to be studied. The time of peak nutrient demands of component crops should not overlap. In maize plus green gram intercropping system, the peak nutrient demand period for green gram is around 35 days after sowing, while it is 50 days for maize. Competition for light should be minimum among the component crops. Complementary should exist between the component crops. The differences in maturity of component crops should be at least 30 days. Perennial crops offer several types of opportunities during their growth. The space between young trees could be utilized for growing crops. Multi-store or multi-level cropping is a system of growing crops of different heights together at the same time on the same piece of land, and thus using land, water and space most efficiently and economically. It is aimed at maximum production per unit area per unit time, wherein economic yields of compatible crop species are harvested from different heights. The basement floor is the same for all species and crop yielding floors are increased for more production. Land use efficiency rises beyond 100%. It is also defined as the cultivation of different crops in different canopy heights in a field simultaneously. Example, areca nut plus beetle vine plus papaya plus pigeon pea plus pineapple plus ginger. Primary companion crops should be quick growing so that they complete their life cycle before the principal crop attains full growth. Companion crops with twinning habit except pepper with coconut should be avoided. Secondary companion crops should always be annual or seasonal, preferably vegetables, tuber crops. Cultivation of legumes as secondary intercrop enriches soil fertility besides giving additional income. Companion crops should not be hosting parasites infecting principal crops. On the basis of dominant crop in the region or zone which covers maximum area, various cropping patterns have been identified and described below. Rice-based cropping pattern. This cropping pattern is found in heavy rainfall areas or in areas where supplemental irrigation is available. The monsoon belt accounts for 46.4% of this cropping pattern, comprising Uttar Pradesh, Bihar, Madhya Pradesh and the multi-season belt for 53.6% including Assam, West Bengal, Orissa, Andhra Pradesh, Tamil Nadu, Kerala and Karnataka. There are 30 rice-based cropping patterns in India. Wheat-based cropping pattern. There are 19 wheat-based cropping patterns in the country with the introduction of photosensitive varieties. It is now possible to grow wheat from Himalayas to Kanyakumari. In traditional areas of northwest India, follow wheat rotation is replaced by moong wheat, red gram wheat because the new variety can be grown from mid-November to the end of December. The availability of short duration varieties of moong and red gram made it a perfect cropping pattern. Similarly, short duration green gram varieties made possible the rotation of potato, wheat, green gram, that is during summer. Wheat cultivation has spread to the rice growing areas of eastern India. In West Bengal, wheat has replaced with urd, that is black gram. Kharif sorghum based cropping pattern. In India, Kharif sorghum is cultivated in the states of Maharashtra, Madhya Pradesh, Karnataka, Andhra Pradesh, Gujarat and Rajasthan. On all India basis, about 17 major cropping patterns have been identified. In Maharashtra, cotton, pulses, groundnut and small millets are sown as alternative crops. The alternative crops grown in other states are cotton, pulses, small millets, wheat in Madhya Pradesh, wheat, cotton, bajra and maize in Rajasthan and groundnut, cotton, pulses and oilseeds in Andhra Pradesh. Rabi sorghum based cropping pattern. In India, the Rabi sorghum is cultivated in the states of Maharashtra, Andhra Pradesh and Karnataka. There are 13 cropping patterns based on Rabi sorghum, of which the maximum are found in Maharashtra with bajra, pulses and oilseeds as alternative crops. Pearl millet based cropping pattern. This type of cropping pattern is found in arid and semi-arid tracts of India, mainly in Rajasthan and Gujarat. On all India basis, about 20 major cropping patterns have been identified with pearl millet. Bajra is grown along with pulses, groundnut, oilseeds and kharif jawar in Rajasthan. Besides these, cotton and tobacco are also grown in Gujarat. Maize based cropping pattern. This type of cropping pattern is practiced in the states of Uttar Pradesh, Bihar, Rajasthan, Madhya Pradesh and Punjab. On all India basis, about 12 cropping patterns have been identified with maize as base crop. In Uttar Pradesh and Bihar, rice in Kharif and wheat in Rabi are the main alternative crops. In some areas, bajra, groundnut, sugarcane, ragi and pulses are taken as alternative crops. Ragi based cropping pattern. This type of cropping pattern is followed in Karnataka, Tamil Nadu and Andhra Pradesh, Orissa, Gujarat, Maharashtra and in the hilly regions of Uttar Pradesh and Himachal Pradesh. The important alternative crops are bajra, jawar, maize, pulses and oilseeds. Cotton based cropping pattern. This type of cropping pattern is followed in Maharashtra, Gujarat, Karnataka and Madhya Pradesh. There are 16 cotton based cropping patterns in India. Cotton cultivation has extended to new command areas in Karnataka. The new short duration varieties have made possible 2 crops of cotton in a year. Gram and other pulses based cropping pattern. With the introduction of high yielding varieties, rice, wheat, other cereals and pulses are relegated to marginal and rain-fed areas. The short duration varieties of green gram, Bengal gram, red gram and cowpea have made them suitable for multiple cropping system. Example, summer moong of rice wheat and moong wheat. Short duration varieties of red gram made possible. Red gram wheat rotation can be grown in the Rabi season in Karnataka, Andhra Pradesh and Tamil Nadu. Groundnut based cropping pattern. Groundnut is sown in 5 major groundnut producing states, namely Gujarat, Andhra Pradesh, Tamil Nadu, Maharashtra and Karnataka. This crop is mainly grown under rain-fed condition. At the all India level, about 9 cropping patterns have been identified with this crop. In Gujarat, besides the sole crop of groundnut in some areas, bajra is the major alternative crop, whereas the kharif jawar, cotton and pulses are also grown in this tract. In Andhra Pradesh and Tamil Nadu, this crop receives irrigation in some areas and rice forms alternative crop. Under rain-fed condition, bajra, kharif jawar, small millets, cotton and pulses are grown as alternative crops. In Maharashtra, both kharif and rabi jawar and small millets are important alternative crops. In Karnataka, jawar is the major alternative crop, whereas cotton, tobacco, sugarcane and wheat are also grown in this tract. There are some efficient cropping zones are identified in the cropping patterns. Efficient cropping zones. The present concept of cropping pattern defines it as the proportion of area under various crops at a particular time in a given area, but this concept has some limitations. The unit of classification is political and administrative. The scientific and natural features such as soil and climate did not figure with greater emphasis. The cropping pattern was determined by the spread of crop expressed as percentage of the total area of important crops. It is not necessary that spread and cropping efficiency will go together. Though the cropping pattern has been evolved after centuries of experience in national perspective, it is not necessarily the most efficient use of land and other resources. No cropping pattern can hold good for all times. It has to change with the improvement in technology and economic factors. Examples: sugarcane and cotton acreage shrinks when the prices are more favorable for grain crops and vice versa. Therefore, a new concept has been evolved which refers to both time and space sequence of crops. It includes the identification of the most efficient crops of the region, which is considered as a homogeneous soil and climate belt, the rotation in which the crop best fits in, and the intensity of cropping. According to the new concept, the most efficient crops will be identified in a homogeneous region and put in the yearly sequence, that is rotation, where they fit best, and the space, that is area, of those crops which are inefficient will be reduced and the area of efficient crops will be increased. This way, by knowing the temporal and spatial arrangement of crops in a region, we can identify the cropping pattern followed in the region. For the purpose of planning the cropping pattern, it is necessary to divide the country into homogeneous regions on some well-defined basis. There can be number of physical, climatological and agronomic criteria. Example: climate index and soil groups, as both are fixed entities and can be better criteria than the political units.